So, good morning. Welcome to my workshop. How are you? Good. Good. Well, it's meant to be a workshop. It's meant to be participatory. So, what I thought what I'd do today is talk about HA clustering for a little bit, and then we have a 3-hour slot. So the idea was sort of the last 2/3 of it we're going to be actually setting up HA clusters on your laptops. So if you have a laptop and you want to try this out, just install VirtualBox and then get the hard disk. We can shove it in there. But yes, anyway. So my name is Richard Brown. I've been working for SUSE for 6 months now. Hey. And I'm a QA engineer, mainly testing HA and iscsi and IPv6 and all this sort of wonderful networky stuff. Before that, I was a sysadmin for way too long. We're using HA for about 9 years, and we were really, really early adopters of iscsi. My first iscsi appliance I built was put together out of sort of sellotape and superglue, and no manufacturer had actually built an iscsi box yet, which was great fun, even if it did work really, really slowly. This isn't the first time I've talked about HA. I was at BrainShare a couple of years ago about how to cluster anything. And most of the time, I contribute to openSUSE. I'm a board member. I maintain GNOME. I also somehow got involved in maintaining all of the branding packages. And I'm probably going to end up stuck maintaining these HA packages at some point. So what does HA stand for? High availability. Keeping your systems running. Or more accurately, keeping the services running that are running on your system. But when I talk to someone new about this, the first thing they almost certainly say is, well, why do I need this? Linux is stable. It just works. And that's partially true. I mean, it's more true than it is with Windows. My old Windows servers crash an awful lot more than my Linux ones. But my friend's going to love this. I ended up finding a quote from a BSD guy. Bugs happen. I mean, if bugs didn't happen, I wouldn't have a job. So, things go wrong in software. And if you're lucky enough that there are no bugs in the software and everyone's done their job perfectly, things catch fire. That actually happened to me in the office, luckily not recently, but yeah, plugging in a hard disk, and next thing I know, there's smoke belching out the side of it, which is always fun with a server. Or, next slide is brilliant. This is actually a video from one of my servers that I did a SLES 11 SP3 update, and everything was fine, and then I rebooted it, and so, yeah. Yeah, well, this was actually like 2 weeks before Christmas. It was brilliant. So we left it running in the office, all the lights blinking, but yeah. Hardware failures happen, and they look really pretty when they do. And even when they don't, this actually also happened in my office. We had contractors in. And yeah, suddenly we wondered, why is our data center not working? And we went down to the basement, and there was our lovely network cables. And this one wasn't actually us, but we dreaded it. A burst water main in your server room. Who would put a water main in the same room as a server room? Wasn't really a smart idea, but yeah, I've actually had data centers with water mains running through it, and I always dreaded that day happening. So HA is there to hopefully keep something running when the servers aren't, or servers fail, no one else can help. But really, yeah, no one. Okay, so the idea behind HA is servers can fail. They do fail. Networks fail. And really, users don't care if a server fails. To them, it's just some magical box in a space somewhere. The bits that matter are the services. They want to get to their website. They want to get to their files. And sort of HA kind of takes that and uses it as a big concept in the HA stack. You're not trying to keep the server running, but you're taking the services, telling the cluster everything you need to know about that service to make it run on any server. Or if you're going for something like active-active clustering, where you want to have it running on every server so you can then load balance across it and do all this wonderful stuff. And the idea is that when that server fails, because it's going to, the service can just, walk away from the carnage and keep on working. And yeah, that's my last of my funny slides, because I ran out of time last night. So this is sort of a basic layout of a very, very simple cluster. So at the bottom here, we have the hardware, the actual physical boxes. These are the boxes sitting in your rack, in your server room. And they're sort of on a traditional network, they're probably given a single specific job. So your web server, your database server, maybe you're lucky enough and you've got some spare servers. With HA clustering, on top, if we put on top of that sort of some cluster software, so in openSUSE we use software called Pacemaker and CorvoSync. That basically lets you stitch together all three of those servers into one cluster. So instead of having 3 individual servers that have no clue about anything else, you end up with one nice cluster which knows about the other 2 servers, so it knows it's 3 nodes. And then sitting on top of that HA cluster software, you configure your services, the actual parts of this, the actual software that's physically sitting on these servers, so the cluster is able to move these services around in the event of a hardware failure. Or put another way, if you imagine here, this is your standard web server with Apache and a database running on it, and you have 2 other servers, a file server and a mail server. With this set up like this, the web server can fail. That will get detected by your cluster software. It would know that Apache and your database server were running on there, and automatically it would take all the IP addresses and configuration and everything it needs to know and migrate it to 1 or 2 different servers to keep that service running. So suddenly it doesn't matter that your network guys have gone and cut through all the cables. So at this point, I was really expecting a workshop rather than a talk. The setup you got in VirtualBox there, you should have 2 VMs, one called Node 1, one called Node 2. Hopefully, yeah. Did they actually import properly? Because I didn't get time to test that this morning. Okay, so if we imagine we had two different servers, let's say one called Node 1, one called Node 2. And one of them was set up to run a web server, like Apache, and another one is just sort of some typical file server. One problem that you quite often get when you sort of first start messing around with all this cluster stuff is, one of those node fails, you've managed to set it all up properly, so Apache moves across and carries on working on the second one, and then your users connect to it, and all you get is that lovely "it works" banner page, because you don't actually have the files on both servers. There's two schools of thought for fixing this. One is we have a bit of software called DRBD, which lets you mirror between two different servers over the network. So you can have a hard disk on one machine, or partition, and every single bit of data that you write to that automatically, magically turns up on the other one, which is really cool stuff. So suddenly sort of this problem where you've moved one bit of software to another isn't an issue. It does, however, slam your network really, really hard, because every time you're writing any I/O to one machine, you're writing network and then extra I/O to this second box. So if you're lucky and you're in a nice big complicated environment, the sort of more efficient solution is shared storage. Something like iscsi or Fiber Channel, or maybe even something like Ceph, some of these new magical elastic file systems that you can put it inside. And so for the one person we have doing the VMs, or have you managed to find space? Cool. Yeah, sorry. This is what we're going to try and set up today. So a very simple two-node cluster with node 1, node 2, and some iscsi storage. All of this running openSUSE. And yeah, basically we'll have the cluster running on the network, beginning with 10, so 10.0.0.1 and 10.0.0.2. And then all this bit down below here, we're just going to mess around with iscsi because it's easier than setting up DRBD because we only have 3 hours. If you want to do this for yourself, when you go home, when you actually have more time, the best packages we have at the moment for HA and openSUSE are in HA clustering factory openSUSE, this nice long URL. They'll be in openSUSE 13.2, and I intend to take those and also backport them for 13.1. Because the basic packages in openSUSE 31 work, but a lot of the sort of extra features, lots of nice extra security checks and stuff like this don't actually work. So you can set up a really nice cluster in basic openSUSE 13.1, and then it can just spontaneously break itself if certain weird things happen, which you want to avoid. And the easiest way to install all the software which you need to run a cluster is actually HA Cluster Bootstrap, which is this one package that pulls through all the other packages you need and gives you the scripts to actually install and run it. So if you were doing this from scratch, you'd add that repository, install that package, and then on your first cluster node, I should have put this on a slide, you run HA cluster init, which will basically set up your first cluster node, does a whole bunch of checks, runs through a nice little wizard telling you everything that's wrong with your machine if you haven't set it up right. And that sort of then ends up setting up a one-node cluster. And then you run it again on a different node with HA cluster join, or HA bootstrap join, and the IP address of the first machine, and it learns all the settings and stuff it needs, so you end up with all the other machines adding straight away, very quickly. Cool, so I'm going to try and, here's one I prepared earlier. Does this work? Yeah. Pardon? Yeah. Hello? There we go. There we go. Can you hear me a bit better now? Yeah, good, fine. No? How about now? That better? Check, 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 yeah. I'll scoot along this way a little bit. Actually, change my display resolution here. That's better. Why is Gnome Shell not working? I want this window to be in that workspace, but it's not.
This is not how it's supposed to work,
I know I've broken. Oh no. I'll just close everything else. I don't need it anymore. There we go. Okay. Let's see. Does it let me use that? No. Fine. Lovely stuff. Shush. Okay, so if you have VirtualBox running and you fire up the 3 VMs, you should end up with one called Node 1, a second one called Node 2, and a third one, which is our iscsi, so it's our shared storage. So if you were doing this properly, your iscsi box is probably going to be some nice black box you've just got in your data center. But one of the nice things with openSUSE is we actually have a fully working iscsi target. In fact, we have 2 of them now. So you can set up any openSUSE box as an iscsi target for testing, or if you want to do it in production, there's the new one, iscsi LIO, which is actually nice and fast and good enough for real work. The old one was really slow. So this VM is kind of just going to sit in the background and not do much, because I've already configured it to be an iscsi target, just like you would already have set up. So I'm not going to necessarily show you that unless you're interested. So let's start with node number 1. And if I'm too far ahead, just let me stop and I can let you catch up. So on these VMs, I've skipped ahead and already added the repository and already added the packages. So it's a bog standard openSUSE install with XFCE, as you can see here. I didn't do GNOME because it was just adding too many packages and I've got to fit on there. But I would have otherwise, because, I do. But it's meant to be a server, so I shouldn't really be using X at all. But it looks better on the slides. Basic install with that minimal, apart from that repository and that one package, which is then pulled through the entire stack. All of the passwords for all of the VMs is cluster. So the root password's cluster, the cluster users cluster. Kept the passwords really simple. Let's try and make this full screen, see if it works a bit better. Yeah, cool. So the node is set up with 3 network devices. The 2 that I showed you on the slide, so the 10.0.0.1 address and the one for iSCSI, 192.168.0.1. You can kind of forget about the 3rd one. I just had to slip it in there for VirtualBox to be able to see the outside world so I could download the packages, and I forgot to take it off. So the first thing you need to do is, once you've got all 3 VMs running, is go to YAST, and log in with the root password of cluster. And we need to connect the cluster nodes to the iSCSI storage, because I couldn't get that to work and then carry on with the import. So with YAST, you can start up the iSCSI initiator. And you want it to start when it's booting. And then this iSCSI initiator module in YAST is kind of weird. You have to discover the iSCSI before you can use it, but the tabs are put in the wrong order. Which, yeah, someone should really fix that. So if you go to the discovered targets tab, and discovery, and then you try and discover 192.168.0.3. Unless I've done something horribly wrong, this should now find the iSCSI target. And it's not working. Yeah. That's not fun. Yep. Good catch. Yay. Okay, so first things first, if you go to the iSCSI VM and log in and fire up YAST, you need to change the subnet mask to 24.255.255.255, because it looks like I set that up wrong on the VM. Which is strange, because it worked. That's the one thing I tested before I came here, and it works then. Yeah, it's fine. that okay? Your iscsi's now got the right subnet mask? Because I really... Okay, so once your iscsi VM's got the right subnet mask, and you can actually ping between the different hosts, this should now actually work. Or not. Hey, the demo effect. What is YAST doing? I didn't open all these windows. Okay, that's weird. I click on iscsi target and it loaded up the NFS configuration. Yeah, same difference. See if that fixes it. Yeah. Sorry, another thing wrong in that iscsi VM. You can either go into YAST and turn the firewall off, or go into YAST and the iscsi target and open the port in the firewall. It's a tick box in the iscsi target section in the YAST. Just there. There, on the iscsi target, on the iscsi host. Do you need a hand?
I have a problem that I can't install the
So the iceland VM and the iceland target. Yeah, you have to restart the target. Actually got the cluster set up yet. So.
It's just a magic that sits next to it.
Yeah, there seemed to be something strange earlier where I clicked on the iscsi. I clicked on one thing and YAST loaded up something else. It might have been that you clicked on iscsi target and it loaded up the initiator, which wasn't installed on that VM because, yeah, so that's fine. So now you should be able to load up the initiator on node 1. And you should be able to get to that window. Famous last words. No, the initiator is on node 1 and node 2. The iSCSI has these really nasty terms like initiator and target. Target is basically the server, initiator is basically the client. So the VM that I've called iSCSI, that is your iSCSI target, that's the server. And then on node 1 and node 2, you need to run the client to tell it to connect to the server. Do you have a question, or are you just looking at it? No? Cool, that's fine. Yeah. Is it misbehaving, or? Okay. Let's come have a look, and if we keep on having problems, we'll just plug your laptop in. Have that on the slides. Yep. It works now. I'm just going to have to stay here. And, yeah. Yeah, that's not working. Let's see if it works on node 2. No, yeah, Node 2 has gone and done the same as my machine did earlier on, where it's loaded up NFS when you click on iscsi, which I'm guessing is a bug. Okay, so Node 2 is fine. Okay. Yeah, so when you first load up that, you need to click on when booting, so it starts up every time. And then in the third tab, not the second, because it's weird, you have to click on discover, and the IP address, which is 192.168.0.3. So once it's discovered, you then go to the middle tab, because that's a good, sensible work. No, you don't actually, sorry. You click on login, which will then take you to this window. And you want to change the startup of your iscsi connection to on automatic. On boot is there for if you want to boot the system into iscsi, which I don't think anybody ever does. And then when you click next, it should take you back to this tab, and on the second tab, it should now also show in there. Cool. So we'll worry about your node 1 in a minute, because luckily we don't really need that for this specific part. So click on OK there. And then back in YAST. And if you go to the partitioner, or if YAST goes crazy and loads up stuff without me asking. Did everybody see that? No? Fine. Might, yeah. Yeah. VirtualBox being a little bit, yeah. Yeah. And in the partitioner, we should see this IET virtual disk. So it's your iscsi disk. It's 8 gigabytes. That's the other one. Yep. Cool. What we're going to do is we're going to make two partitions on there. One of them 100 meg and not format it, and the other one the rest of the space, and we're not going to format it either. Otherwise it will eat up all your hard disk space with the VM. So right click, add partition. Primary partition. $100 megabytes. And we are not going to format it. We're not going to mount it. This is going to be for a special cluster feature called the SPD, which has lots of different acronyms. It's basically a heartbeat mechanism for the cluster nodes. So in the event that they can't talk to each other over the main network, they talk to each other over the storage, which gives them the ability to, well, one of them to kill off the other if it's misbehaving and stuff like that. there's our 100 meg partition. And then there is the rest, which we will use later on. Now at this point I would normally go to the other node and redo all of the iscsi stuff, but given we know on your machine it's already broken, I'm going to just... Okay, great. So yeah, on your other node, so in my case node 2, in your case node 1, you should be able to connect to the iscsi. And then when you go into YAST partitioner, you should not only see the disk, but you should also see the 2 partitions we just made. It did it again. Every time I type like R into the search box in YAST, it loads up random things. That's fun. Yeah, app armor. Hey. There you go. So now on node 2, we have the iscsi connected. And on node 1, we also have it connected, which is perfect. So in partitioner, if you click on the 100 meg partition in the left-hand column, there is this really nice long device ID. Which we need to copy because we're going to use it. We're going to be asked that question during the configuration wizard for the cluster. Yep. Yeah, okay. Control C hopefully will work. Let's see if that's actually copied it, because I don't want to type that out. Yeah. Okay, yeah, Control. That's weird. That's fixed in factory, by the way. Because I did this on factory like 2 days ago and it was fine. And then I thought I really should do this on 13.1 for the presentation. So yeah, it's fine in factory. So in a terminal, ideally on node 1, switch to root. And we're going to run the nice, useful wizard HA cluster init. And yeah, if we have a really quick look at the help file, there's lots of nice switches where you can automate all of this, but we're not going to use any of that. So just HA cluster init on its own. We press enter. This automatically does a sort of sanity check on your configuration. It checks things like NTP's been set up properly. If it finds the firewall, it opens up firewall ports. It automatically configures your SSH to use key-based authentication, because the cluster needs to do that to talk to each other, to copy files and stuff. It now asks to configure the CoroSync messaging layer, and it's gone and detected the wrong device. So it's asking for which IP address to listen to for the CoroSync cluster configuration. And it's gone and found the device that I didn't want it to use. So in there, we type in 10.0.1 if you're on node 1, or 2 if you're on node 2. And press enter. The cluster requires a multicast address in order to be able to talk to each other. This wizard just literally picks a random one and assumes it's going to be available. So if you're running a busy network, you need to actually allocate that, type in the proper one here, but in our case, we can just press enter. Same for the multicast port. So this is the SPD, the shared storage to avoid split brain scenarios, which we really should use on any cluster that we can. So we want to use it, so we click yes. And then it's going to ask for the file path, for the device path, which is dev disk by -id, and then hopefully we can paste it in from YAST. And it's going to say it's going to wipe everything. We don't mind. It's off. Yay! So we now have a one-node cluster, which is completely useless. There's basically two different tools for managing your cluster. One of them is called CRM, which is the command line tool. And you can run, for example, CRM status. Which will show the status of your cluster. It shows the current nodes that are there, the services that are configured, all of that stuff. And there's a web interface, which load up in Firefox. When Firefox decides to load, there we go. Which runs on port 7630. And then this is called Hawk, the High Availability Web Console with a K, because I guess the guy was a KDE user. Or just wanted to make it sound right. The default username and password is HA Cluster, and the password is Linux, which is really insecure, but I haven't gone and changed it. And this gives you a nice web interface, which is a little bit easier to read than the CRM stuff, where we can see the nodes in our cluster, so the one node we have configured. And the services we have in our cluster, so the SBD is configured as a service in the cluster, so that's the one we have sitting there right now. And I'll go through all of the stuff later. So on node 2, here we are. We now want the second node to join the cluster. So in a terminal, switch to root. And I've forgotten the parameters for this, so I'm going to have to type help to remember. So yeah, clusterinit is the command you use to set up the first node. clusterjoin is the command you run on every node after that to make it join the cluster. And it requires one parameter, which is -c, and the IP address of an existing cluster node. So in our case, 10.0.0.1. And if all goes well, this will then do the same sanity checks that the other one did. Same configuration with SSH. Because this node didn't have key-based authentication set up initially, it's probably going to have to ask for the root password. And then after that, it should do everything automatically. I hope. I really hope. Or not. Okay. I know what I did. I left the firewall running on node 1, and it's probably not got SSH open, because, yeah. So let's just turn it off on both nodes. It'd be easier. Yeah, we'll do it in YAST. I'm really not sure what the heck is going on, because I'm not actually touching the keyboard and stuff's loading up. VirtualBox is magic. Okay, so on both node 1 and node 2, if you could fire up the firewall bit in YAST and just disable it and stop it. If you're doing this properly, you'd configure it to, have SSH open. But I'm getting fed up of fighting. That's node 1 done. Get lost. I don't know. Has anyone seen YAST do this before? Yeah. It's got to be, but it's just bizarre. Yeah, you click one thing in YAST and 10 windows load up. And it's like random ones like NTP and repositories. And the firewall again. Printers. Proxy configuration. Hey. Okay. So with the firewall turned off, our HA cluster join will now actually work. Hey. It works. Two nodes. Oh, you off? Have a nice trip. Is it working? Yep. Two nodes. Cool. So CRM status on either node should now show the same thing, hopefully, which would be that. Both nodes. Two configured. Yep. Or if you prefer in hook, it should now show two nodes. So now, basically, it's a case of setting up all of the resources that you want to run highly available on your cluster, which could be millions of different things. So I'm going to start with a really simple one, which is just an IP address. I've actually used this more than any other because it's really useful when you have, especially when you have like really weird, nasty third-party products that don't want to work properly in a cluster. And you can at least install them manually on each node, and then just use the IP address to move it around. And that's the IP address you tell all your users to connect to, and from their perspective, it's highly available, even though you've managed to get yourself 3 instances or 4 instances of this software to run. So we'll use Hawk for this because it's fun. It makes a change. So on the left-hand side of Hawk, I can't remember what the icon is. There we go. Second from the bottom, resources. And the terms are a little bit weird, but primitive is basically the service in page A. So we're going to take the little plus next to that. Now, the resource ID is just the name of the service. So we're going to call this virtual IP number 1. And we're going to ignore those 2 drop-down boxes. And we're going to click on the third one. And so these resource agents are effectively the services that the cluster is already aware about. So most of these, I'll just, for example, click on Apache. Okay, I can wait, no rush. How much memory is on the laptop? 4 gig? Yeah, I might have done a better job of optimizing it for 4 gig. I kept the VMs as 32-bit. I tried to keep the install minimal, but 8 gig, well, that's the same as me, so I don't feel guilty now. Hello again. Hey, Jan Weber, everybody. Okay. Okay. So yeah, these types are different resource agents which the HA cluster already knows about, and therefore it has sort of all the parameters and configuration and knowledge it needs of the service it's going to make highly available. So like for example, for the Apache one, all you would need to tell your cluster is, you know, basically what your monitor time needs to be, start, stop, etc. And then it'll find the Apache running on that machine and start, stop, monitor it. Done. So in our case, we want to set up an IP address to float around the cluster. And in this drop down, there's two of them, IP ADDR and ADDR2. ADDR on its own is just IPv4, and with the 2 on the end, it's IPv4 or IPv6. So as we're a boring IPv4 network here, doesn't really matter either way. And then Hawk has popped up one parameter it needs, the IP. So in there, we can just type in the IP address we want the resource to have. So we've already got 10.10.01 and 02, so this will be 03. We can kind of ignore the rest. The defaults for monitoring and seeing how long it takes to start and stop are perfectly fine. This here is basically, do we want it to automatically start or stop and then be started manually, initially on configuration. So I'm just going to leave it as stopped. And then we click resource. And now if we go back to the first part of Hawk, we now see we have two resources. And virtual IP1 is stopped. So that's where I wish I had a bigger screen, but what I'm going to try and do is in the corner here, see if this works. Set up a ping, pinging 10.10.03, and if you ping, you can see it's not working. But then in Hawk, if you go to the resource and click the little button on the right-hand side, and then click Start. Do I want to start? Yes. And then our ping is now working. And I don't actually know which node this is working on at the moment. Back in Hawk, I can click on it. I can see this is running on node 2. So if I was sending users to that IP address, they would currently all be going to node 2 and getting whatever service we're using this for from there. Now, in Hawk, if we wanted to move it, all we have to do is click on that button again, click Move, and we can say which node we want to move it to, or just I want to get it off this server, and it will randomly pick whatever's next, which is what the default is and what I'll leave it on. So this is actually taking the IP address, disconnecting it from the server it was on, node 1, and it's moved it to node 2. And in fact, it did it so quickly that my ping didn't even notice and drop a packet, which was kind of nice. So that's sort of looking at it from a Hawk perspective. With CRM, So if you want to do it from a command line point of view rather than a nice shiny web interface, CRM kind of has two modes. One, it's a command that accepts lots of parameters. But CRM is also a fully functional shell. And you can actually use it as an interactive shell for talking to the cluster. The nice thing with CRM, when you're running it as a shell like this, is the tab completion is absolutely wonderful. So you can forget about what you're doing half the time and just hit tab all the time and figure out what it's going to assume. And it's got ridiculously comprehensive help, which is kind of strange. Hawk is meant to be the nice, friendly user interface one. And most of the time I end up having to load up CRM to actually read the help files because they're more useful. And then use Hawk to actually do it, which, yeah. We're going to try and fix that, I think, because it would be nice if we had the help in both. No, my mistake. Okay. Yeah, so everything you can do in Hawk and more you can do in CRM. So just to sort of show the same thing we just did earlier, in CRM you can do resource and migrate, and the tab completion will even figure out which resources you've got set up, which is nice in case you forget the names. So at the moment, virtual IP address 1 is running on node 1, I think. I think that's where I put it, yes.
My virtual IP address has stopped and I can't start the virtual address again.
Oh, I'll come have a look. I don't know. Okay. Can't know everything. So, let me just have a quick look at what I was going to do next. Yep. So, on one of your nodes, node 1 or node 2, we're going to set up OCFS2 file system. So OCFS2 is a file system that can be used active in a cluster. So both nodes can mount the same file system, both nodes can write to it, and there's a lock manager which will set up to handle all of that nasty stuff that could possibly go wrong when you have two nodes writing to the same disk. In YAST, and hopefully it won't load up random stuff this time. In the partitioner, we're going to go in and we're going to get the device ID for the other partition. So oh, it's because I already have it open. Okay. So once you've got the device ID for the other partition, Hawk has these really nice wizard options, which at the moment just cover setting up web servers, OCFS2, and NFS. But in the future, there's ideas about having it pretty much probably do wizards for most of your cluster configuration. So instead of having to do all of the manual stuff in Hawk or CRM, you can just use these wizards which spell out what parameters they need. So, problems again? The other option, you could just go to, you could just load up a command line, go to dev disk by ID and just ls, and it'll be the one that mentions SCSI in part 2, because there's no other SCSI disk on the machine. Yeah. We're in VMs, we can cheat. Okay. Cool. So in Hawk, in the wizard section, OCFS2 file system, and what this will do is it will configure everything in your cluster that it needs for OCFS2. So it'll make the resources for OCFS2, resources for the lock manager, but it won't actually format the file system. That we have to do later, which is mainly there to make sure that the lock manager actually works before we start, needing it. So this is the name of our cluster resource. So I don't like calling it cluster FS. I prefer calling it OCFS2, but call it whatever you want. In the block device section, we put in dev disk by ID and the ridiculously long string, which for me isn't pasting. There we go. the mount point is the mount point for, on all your nodes, wherever the file system is located. Serve cluster FS is kind of good enough, so we'll leave that. File system type is OCFS2. In theory, you can use this with cluster and various other sort of similar cluster file systems. But OCFS2 is what we currently have packaged up for openSUSE, so that's what we get. And mount options, Hawk has the ability to put them in there. I've never used a mount option for OCFS2 ever, because I think all the auto detection stuff always works. And whenever I try and override it, I end up breaking the thing. So I just leave that blank almost always. This here is Hawk being nice and helpful. If you wanted to do this in the command line, these are the commands you'd have to type. Which kind of scary, but it's actually a good way of learning the CRM way of doing things. So the primitive, that's the resource for OCFS2. The parameters are the parameters for it. This bit here is the lock manager, the DLM, for handling the locks between both nodes accessing the file system. And because this is unlike a failover resource where it's only going to be on one node at a time, but actually it's going to be on every node all the time, it's then cloned so it will automatically exist on every single node. So we click next. And in Hawk, we should see that the DLMs have started, but the OCFS2 has not, which that should be fine. Yep. And then on either node, doesn't matter which one, we can now format the file system for OCFS2. And this can take a little bit of time. Oh, that was surprisingly quick. Okay, this means that our laptops are faster than my test hardware, because this takes like 5 minutes back in the office. Okay, so now we've formatted the file system, we can actually start the resource. Because it's grouped, we actually have to click on the parent in Hawk and then click Start. And it failed. That was unexpected. Did it work on your machine? No, it's fine. No. Okay. That doesn't look very healthy. At all. And that's not working. Come on. That's not very good. Strange. It worked when I tested it. And this is why I shouldn't have updated the VMs this morning. Yeah, what seems to have happened is, despite OCFS2 being installed and running and loaded, and even with the OCFS2 user daemon there, for some reason OCFS2 can't be found when trying to mount the file system. That's a bug. Well, we can forget about that. In Hook, if we go to the resources, and the OCFS2 clone group, we can delete it. Might as well tidy up the mess that it's made. And we can delete the OCFS2 primitives. There we go. We're going to leave the DLM there because given OCFS2 is broken, what we'll set up instead is we'll try NFS with a LVM volume. So it'll be a CLVM volume with NFS running on one node, which we should then be able to move from one node to the other, which is another really, really common basic use case. And that'll need the DLMs, so we might as well leave them there. So yeah, we're going to use this wizard instead in Hook. And yeah, okay, worry about that later. So let's live dangerously and load up YAST partitioner one more time. Or if you, like me, already have it running. Yep, no rush.
Partition that is fine.
Yep, cool. We should be able to get to volume management, and we should be able to create a volume group. And we're going to create a volume group using devsdb2, which is our second partition on our iscsi. And then inside there, we should be able to create a nice logical volume, which, if we felt like it, this is where you could use thin provisioning and all these lovely new features we have in 13.1, but we're just going to use a normal one in this case, because we've already had one thing not work horrifically for no good reason. Using up all the available space, and we're going to format it as exe4, but we're not going to bother mounting it because Hawk should take care of all of that as part of the NFS. Yeah, just ignore that. That's XFCE being a little bit overzealous, and it's found the new LVM volume and wants to mount it straight away. Which, yeah, nothing like a GUI to be awkward. So the NFS server wizard is a little bit different than the other one. It's a bit more involved because it actually goes into the nodes and changes things like NFS configuration. So it'll need the root password, which you don't want to remember. Oh, did I miss a step? Yeah, sorry. The problem with doing it on the fly, I forgot to do something. So we've created the LVM configuration, but we haven't actually created a resource for it to then NFS enable. So in Hawk, and the resources section, we're going to create a primitive. And we're going to call this base file system would be fine.
Some problem that he hadn't created, so I should have won.
Oh, I'll just check it worked on mine. Let's have a look. Yeah, no, mine's okay. What error did you get?
System error 3000.
Yeah, nice, detailed, useful error message.
The partitioner has crashed again.
I was hoping, you see, doing it all in virtual machines, you know, it should be consistent on all of our machines, and it should be fine. Yeah, with the same VMs, I have, yeah, so much for that theory.
Is there some option for YAST tool that it's that is only in the console and not provided everything?
Yeah, if you YAST to -- n curses. And that's actually how I normally use it. I don't often have a X session.
I hope that it will work. Then I will try and console. It's kind of bad.
You've got 2 nodes. How about the other node? The same? Let's have a look.
on this?
Oh, yep, good catch. Oh, do you want? Good, thank you. Yeah, so in Hawk, we're going to create a resource of type file system. On the right-hand side, we have all this nice help text. It explains what all these parameters are. So the device is a block device. In my case, LVM. In your case, just a normal block device. In the directory, we're going to mount it in serve cluster fs, which is where we were trying to mount OCFS2 earlier, so we know it's there. And you don't normally have to put the file system type, but we might as well put it in here just in case. So here we are, we now have our file system resource made. And we should be able to start it. Oh, come on.
My laptop has worked.
On your laptop it worked, okay. So there's a problem in CLVM somewhere. So I will just let it quickly fix this. I hope it is, yeah. See, I use the latest packages because it's what we have in SLE. Make a fresh one. Put it in the device, okay. Made. Start. For you.
So you must remove the logical volume on the device because now you directly install the start
Yeah,
device.
no. You're right. Yeah.
Partition.
Watch me make a mess of things. Nope. Okay. Yes, I want to continue. Why are you not working? Let's see, maybe it's blocked by. Yeah, it's fine. Yeah, clean up. If it detects a critical failure, the resource will basically be sort of put in a maintenance mode. So cleanup clears that out so you can actually start it properly. So we're both on the same page now, which is good. I'm going to stop it well, let's actually check that it mounted properly. So which node did it mount it on? Node 1 for me. So In cluster FS, I should have lost and found. I do. I should be able to make a test thing and test 2. Yeah, I can make files. That's okay. And then I should also be able to migrate it in theory. So let's change. Yeah, cool. So I've just migrated the file system from node 1 to node 2 and checked, and now it's mounted on node 2 with my test file and my test folder in there. Nope. Because we're using the raw file system and not CLVM, you probably have something holding the mount point open. So make sure like your console isn't CD'd into that folder or something like that.
My first node hasn't mounted the file system.
But the service is started on node 1.
My service is started on node 2.
So it should be mounted on node 2.
Yeah.
But it's not.
It's mounted on node 2, but node 1 hasn't heard anything before. Is it right that only the node 2 have mounted this file system?
Yes.
Okay.
Yeah, that's fine. Yeah, because because we're not using OCFS2, so we're not in a position where we can mount it on all servers at the same time. So it's just sort of a standard file system with no cluster awareness, and therefore you only can have it active on one machine at a time. But in the event of failure, it'll appear on the other one. So if we're using this with, let's say, like Samba, or as we're going to do with NFS in a second, it'll move all of the services it needs to start it up. So back in Hawk, back with our wizard. Should be to start the NFS server wizard. Yeah, third one down. We need to put like text next to the buttons in Hawk. So the wizard asks for the file system resource, which we've got base FS. And then this is all of your bog standard NFS configuration stuff. That's the name that it's going to be called in the cluster. That's the file system ID in NFS. That's the mount point, any client configuration spec. And then the exported file system. Same again, I can just click next for all of this. Will it actually work? Yeah, no, that should actually work. We need an IP address. So this is going to make a whole bunch of resources all together in one big group for sort of our NFS thing. So 10.0.0.4. And for some reason it needs the net mask as well, which normally it can auto detect. But we might as well put it in as 255, 255, 255 not. Once again, Hawk being useful and telling us all of the stuff you'd have to type in by hand if you weren't using it. No. Why does this work in testing but not when I'm here with other people?